Hey guys, today's episode is about immersion cooling. To get an understanding of what that is, we have the co-founder of Rosseau with us, Daniel Koff. I think I said that wrong in the actual interview, but it is Rosseau. Rosseau delivers world-class Bitcoin mining operations with immersion cooling solutions that provide record-smashing power density, scale, and affordability. In this episode, we learned about immersion cooling, its origins, how it's on its way to replace air-cooled Bitcoin mining, and the opportunities that lie ahead. So, without further ado, Alex, let's get this show on the road. Hey, I'm Martin, and welcome to Friedmen. This is Alex.
Hello.
Hello, and we are joined today by our very special guest, Daniel Kopp from Rosseau Immersion.
Hey guys, good to be with you.
And as you can see by the topic of our podcast today, it will be about immersion cooling, and we're very lucky to have Daniel here, who is definitely at the forefront of the field. So I think we should just go straight into it.
Yeah, let's start with some basic question regarding immersion cooling, because me and Martin, we don't really know anything about it yet. So we have an eager ear here to get an understanding what is immersion cooling.
Daniel. Sounds good. Yeah, and please ask questions anytime along the way. We can steer it whatever direction. But high level, immersion cooling is basically a process of taking a device, typically a GPU or a Bitcoin mining ASIC, and actually submerging it into a special type of fluid, which helps to move the heat out of that device more effectively than traditional cooling methods, for example, air cooling, where you're simply blowing fans at the hot parts of those computers. Liquid transfers heat many multiples better than air does. And so you're taking advantage of just good physics in utilizing liquid to provide that heat evacuation from the devices. And that's really important because number one, these devices are only getting hotter, and heat generation in electronics can create things like electrical resistance. It's obviously consuming a lot of power, and excess heat can lead to something called thermal throttling, where your miner or your GPU starts to sort of power down in terms of the number of compute cycles it's producing. Reducing its clock speeds is what it's referred to as, to prevent that overheating, which of course then lowers your computing performance. There's also other heat challenges like component degradation that you can see with things like thermal cycling, where the device is constantly getting hot and cold. And so by putting it in a liquid immersion environment, it's in a much more thermally stable environment because you're removing that heat so the devices don't waver in temperature too much. So this improves your device efficiency, longevity, obviously overclocking performance, something very important for the Bitcoin miners. And all of these things, I think, contribute to really better Bitcoin mining operations. And so as we're seeing the power density of ASICs growing and GPUs as well, we're seeing data centers and Bitcoin mines adopting immersion cooling. I think it's becoming a standard along with direct-to-chip cooling for these data processing intensive applications like Bitcoin mining and AI.
So thank you. That's great. Do all Bitcoin miners have this immersion cooling, or do they have a mix, or what is the template that maybe has happened in the past, and how is it changing?
Yeah, so it's changing quick. So I would still say that immersion is emerging. It's not yet, mainstream. Having said that, it's definitely something that basically every Bitcoin miner just about is looking at today. And many have adopted in force, and in fact are more or less exclusively focused on immersion, at least to the best of my knowledge. So, companies like CleanSpark, are definitely leaders there. Folks like Galaxy Digital, Riot, the list goes on. There's a number of others who are really focused on immersion cooling. And then, I'm reflecting on a dinner we had with MicroBT's CEO in Dubai not too long ago, where he said 2024 would be the year where over 50% of the ASICs they sell will be liquid cooled. So while I would say just guesstimate, immersion is probably at about a 5%, of total hash rate, maybe less, is being produced in immersion. I think we're going to see that number jump dramatically. And I would say within 24 months, in my view anyway, we're going to see at least 50% of new Bitcoin mining builds be done in immersion. I think continuing to rely on air as these devices get more powerful is going to become, let's just say, a bit more of a legacy approach going forward.
Because I have seen that some centers are based near water. Is that because they're water cooled, or I mean, yeah, is there a reason why they're near water?
For sure. I mean, water's one of those liquids that can provide better thermal transfer. You don't necessarily need water to do immersion cooling, so you can use something called a dry cooler, where basically you're cooling down the oil that's entering into this cooler by using fans on the exterior of the building, and then recirculating that recooled oil back to the immersion system. In terms of folks parking themselves near water, that certainly could be because they want to enhance the effectiveness of that dry cooler by using some water to further push the temperatures down. You may also see that in direct-to-chip systems, and even some air-cooled facilities do use water. For example, these water curtains, where they'll basically blow that water towards the machine, hopefully not too close so you don't result in the machines getting too moist, but helping to cool that air before it reaches the fan and the interior of the miner.
Yeah.
All right.
So what can you tell me then? So this liquid, you said you can use water, but you also said oil. So what is the properties of this liquid, and is it actually in the computer, or you said it's moving out as well? So Alex, I think you have a picture, don't you? Maybe.
Oh yeah, I do
could
have.
talk a little bit about
How
it's actually set up.
Yeah, perfect. So yeah, to your question, Martin, that's exactly right. What you're seeing on the right here is a bunch of servers. These are traditional data center servers that are immersed inside of the liquid. So that liquid, there's a few different types, but generally speaking, they're oils that you put it into. And the key thing there is they're termed dielectric fluid. And you can think of that dielectric meaning kills electricity, right? It does not allow for the conduction of electricity. So that's why these computers aren't being fried, right? They're not, sitting inside of water, which would be a conductive medium, right? Yeah. Inside of the oil, they don't experience that issue. And then basically what's happening is the cool oil gets injected at the bottom of these servers, in the bottom of the immersion tank. And then that oil rises, and through, big terms here, convection, stratification, right? Basically, they collect heat from the chips on each of those computers, right? And then you've got hotter oil now at the top, which is then evacuated out and then sent to, for example, a dry cooler, right? Where it gets recooled before then that recooled oil is now injected back into the bottom of the immersion system. So that's kind of the nature of the process. And then in terms of the types of fluids, as I say, there's different types, but generally speaking, they are oils, hydrocarbons. Some folks, use mineral oils, other things. We can talk about why maybe we don't recommend some of those kind of budget options when you're thinking about the longevity of your IT equipment and best performance. But yeah, that's basically what how the system works, and it's a really nice environment for a miner. I kind of like to say it's like taking your miner or any server to a spa. Because you're basically immersing it, in this perfect environment. There's no dust and debris that's entering into the server, right? Which is one of the main killers of these machines. Thermal cycling, right? That hot cold that you get as air temperatures change, right? You dramatically minimize that, which again further improves efficiency, longevity, performance, stability of those devices. And then finally, you don't need fans, and so you're really, by submerging that device, eliminating three of the main causes of these ASICs and these servers failing, which is, of course, good for miners, good for data centers.
It seems like an ecosystem there. Is it, how long time can you use the same liquid? Because it seems it kind of goes in a circle, right? You take it out through a dry cooler and use it as an input again. Do you ever have to switch out the liquid?
Really good question. I would say you treat it like CapEx, meaning you treat it like an investment that, more or less you're going to make once, and it's going to last you for years and years and years. Now, of course, you want to take good care of it. Don't pour water into it or something like that, right? Obviously. But provided that you've got, even some basic filtration systems, for example, the Rosseau immersion system has, built-in filtration systems that will make sure your oil is continuously cleaned. This fluid should last a long time. So, as long as it's maintained, it's clean, which is pretty simple to do. And then as long as you're not spilling it, obviously, you'll have the fluid for a very long time, 10 plus years, highly likely. So it's definitely not something you're going to be replacing on a regular basis.
And do the computers need to be specially designed or be fitted with something, or are they just ready to be submerged?
Yeah, good question. So a little bit of variability depending on which computer, but generally speaking, if we're talking about the vast majority of ASICs, you can just dunk them in. If they're originally air-cooled ASICs, you might want to disable the fan because if you keep that fan spinning, it is going to consume electricity, sometimes as much as 300 watts, which you'd really rather take all of that power and direct it directly into hashing instead of spinning a fan in oil. So there's, some pre-work you might want to do. If it's a used machine, you may want to clean it off, make sure there's no dirt and debris that you're now putting into the immersion environment along with the ASIC. But kind of other than that, sort of just, making sure it's prepped. Generally speaking, you can just put it right in, plug it in, and turn it on, and you can start hashing.
It's it sounds like an amazing technology. How did it come about? Do you know the history of this method?
Yeah, so I can talk to it certainly at a high level. Immersion's been around for a while. So this really goes back to the 1950s and 60s. Immersion can be traced to kind of the early days of electronic computing, where you had liquid cooling methods that were being used to manage heat by vacuum tubes and early transistors. So IBM was a pioneer in this area. I think they had something called the 7030 Stretch, was a mainframe computer that they had, where they used some liquid cooling. This goes back to the very early 1960s. And then, really the technology never became terribly widely adopted back then. It's improved in the sort of 70s and 80s with 3M introducing certain fluids that had been used in supercomputers like the Cray system. And then kind of fast forward, Martin, I would say that the technology's really matured in the 2010s. And interesting, I know we're on a Bitcoin podcast. Bitcoin miners have been doing a lot to drive the adoption of immersion cooling. And it comes down to, miners have actually ASICs are some of the most power dense devices that are on the market today, even compared to traditional servers. So if you just think you've got a concentrated amount of heat, right? Air is just not keeping up with that concentration of heat in terms of allowing the machine to work properly. So miners have been early adopters of liquid cooling to accelerate, the heat evacuation, improve the performance, efficiency of their machines. And they're in a incredibly competitive market, right, in Bitcoin mining, where it's important to get, every last ounce of advantage that you can. And liquid cooling infrastructure is definitely a massively important way to do that. So yeah, I think 2010s were kind of where it sort of matured, and then I think 2020s is the decade where I think you're going to see more or less the wholesale adoption of immersion cooling in the Bitcoin mining space, in the data center space, for the more data processing intensive applications. So
you've been working in this field. How long have you been working in this field?
Yeah, so data center industry, I've been in for a little while, but the immersion cooling space, Rosseau as a company started in 2019. We recognized that there was going to be this need for liquid cooling solutions. We're Bitcoin miners ourselves, looking around for an ideal solution. We tried a number of solutions from different providers, and frankly, we're left wanting of sort of better service support, performance, reliability. I have a background in building companies that do hardware development. I've been based out of Silicon Valley area for the last 7-8 years. And so we decided to basically hire a world-class team, data center experts, data center infrastructure folks, including Rick McGarrison, our CTO, who leads immersion cooling requirements for the Open Compute project, which is a big initiative started by Facebook to create standards in data centers. And so, yeah, I think world-class team came together to deliver a solution that has a number of advantages relative to the technologies that have come before it in terms of things like power density, scalability, right? I think we've worked really hard on cost and speed of deployment, to name a few other things. So yeah, that's really kind of the origin of Rosseau. And so yeah, I've been in the space for, I guess you could say about 4 years myself.
Oh, cool. Because you mentioned cost there. What is the cost difference? Because air cooling has been used for as long as ASIC's been around, right? If we look at Bitcoin mining, how is immersion cooling compared to air cooling in terms of cost?
Really good question. So I would say the cost of immersion is rapidly approaching the cost of air. So there's still probably a small premium on the upfront CapEx. The way that I think you can justify that quite easily in many cases is sort of two things. Number one, I would say if you're looking at high performance, you want to do a lot of overclocking, take advantage of low cost power. It's possible then to push the miners much harder. So instead of a miner, let's say the M66S from WhatsMiner, just one model in particular, typically operates at around 5,500 watts and produces 268 terahashes. With our overclocking system, the Rosseau immersion system, we can push that stock 268 device up to 403 terahashes on average. So basically about a 50% overclock for approximately 10% change in the power efficiency. And so what that means is you can buy fewer ASICs to get the same amount of hash rate. So in some cases, you're saving upwards of 35% on your ASIC purchases, and ASICs being 70%, maybe more of your total CapEx cost. That's a massive savings that actually is more than the cost of immersion. So that's one way right up front that you end up lowering your total cost of ownership by basically buying fewer ASICs and overclocking them. The other thing, and I think is very, very common and becoming widely appreciated, is the OpEx savings. So you've got way fewer techs that you have to have because, again, you're taking these miners to the spa, right? They're in this ideal environment, right? There's no dust, debris, the temperatures are stable, all these good things. You need far fewer techs. You have far fewer consumables like fans and other things that need replacing. You're not cleaning out dust and debris. You're not replacing miners as often because they're lasting a lot longer. So for those reasons, I think if you think about going forward in terms of your OpEx and savings on that side, you're dealing with much more stable and efficient operations. So that's kind of where the CapEx savings comes in, and then the long-term OpEx savings when it comes to immersion versus air.
All right. When you talk about overclocking and underclocking, what does it mean? Can you expand on that? Yes,
for sure. So the way to think about it is overclocking, and I guess it's different from data centers and Bitcoin, but we'll talk about it from the Bitcoin perspective. It's basically taking a machine like, a V4 engine and making it into like a V8 engine in terms of its performance. So, I go back to that one example. You've got a machine that does 268 terahashes a second. So that's kind of its nameplate rating. That's the V4. And using a combination of firmware to basically drive that machine harder, and then great cooling, which allows those machines to maintain optimal temperatures, you can push the clock speed on that device higher. So the key message here would be that the clock speeds on ASICs are not constrained other than by the power supply and by your cooling. So if you have the ability to cool these devices properly, you can basically push the clock speed much higher until the point that you're using all of the available power on that power supply. So that's really great because in Bitcoin miners want to squeeze every bit of juice they can out of their machines, right? And then of course there's some efficiency limit that you want to be kind of working within, but all things being equal, you really want to be squeezing as much as you can out of it. So yeah, that's really where I think immersion cooling unlocks overclocking, right, and the ability to do more with less when it comes to the ASICs that you're buying. Underclocking is kind of the opposite. It's basically where you're trying to maximize efficiency. So you're okay to maybe produce fewer terahashes as long as you're using less energy, less joules per terahash or watts per terahash, same thing. So that's kind of different miners will take different strategies if they're more worried about being efficient, lasting the test of time versus they know they've got low cost power. generate as much revenue as quickly as possible, save on CapEx by buying fewer miners, these types of things, if that makes sense.
All right. Can it also be a play for different companies who have different miners? So maybe miners from 5 years ago, they might have a different approach on those miners when it comes to over and underclocking versus miners they have bought today, for example, that are more efficient.
100%. Yeah. So I think, and again, every miner's got a slightly different strategy. But yeah, generally speaking, what we see is if they've got lower cost power, whether it's older miners or newer miners, they want to be doing overclocking, taking advantage of the fact that they're pretty much always profitable, and so it's just generate as much Bitcoin as they can. If your power cost is high, or if you're dealing with older miners or both, some folks might say, well, I'm going to try and operate more efficiently because the older generation miners just naturally are not quite as efficient as some of the latest devices that are coming out. So yeah, it really is kind of client specific and site specific how you might think about overclocking and underclocking as a strategy. And there's even miners out there who of course have power rates that are quite variable, and so they might choose a combination of strategies. When power costs are high, they'll operate in normal mode or underclock. When power costs are low or the Bitcoin price is high, they'll look to do overclocking to take advantage of that period of time. So really all of the above could fit into any miner's given strategy.
So is there a tipping point in terms of, so just say there is a company that has a data center and has air cooling or water cooling or a mix, and they want to get you in, or your company in. How long are their computers going to, well, maybe you've done this before, maybe you have, can you give us a case study about maybe how long it took and some issues that arose and things like that? If that's probably maybe a better way to explain how someone might engage you.
Yeah. What's the process of adopting immersion cooling? If that's kind of the question you're asking. Yeah. So generally speaking, electrically, you have all the same stuff as air. So right there, a lot of infrastructure can typically be reused. If you've already got a Bitcoin mining facility, you can keep a lot of your electrical. And then when it comes to the cooling side, we do things, I'll say pretty rigorously. We take a data center approach where we're doing, optimizations for a specific site. So we don't provide, an off-the-shelf cooler that you'd want something that's really designed for, if you're in Texas, you want it designed for Texas. If you're in, Nebraska, you want, something different, right? And so, we do all that sort of what we call upfront engineering work to make sure that, we're sort of designing appropriately for the customer's environment, and also designing, to the earlier question, Alex, about overclocking, underclocking, for their specific miner profile. And so Rosseau, we are operators. So we do have a 2 megawatt Bitcoin facility in Austin. We use that to really work on our products, iterate, and obviously do a lot of testing with different miners. And so that gives us a lot of insight in our ability to tell customers, hey, if you want to operate with this miner at this location, here's the type of equipment that you're going to need, specifically in your region, your ambient environment, all of those sorts of factors. So that's kind of step one, is just doing the upfront engineering work to make sure you're designing the right solution. And then from there, typically in 90, 120 days, we deliver the solution. Our team will also do the turnkey deployment of that solution. So it's a pretty quick turnaround between the time that they hit the order and then they're online and hashing at a world-class level based on the results we've been able to provide. And really the kind of requirements, you just need a building, for example, with a relatively level concrete floor. It's a pretty basic structure. You don't need any air handling systems, any air conditioning. It's a pretty basic building that you can put it into. We do have a containerized system as well if you don't have a building. So yeah, beyond kind of just making sure that you've done the upfront engineering work right, the actual process of implementing immersion is pretty straightforward, and then managing on an ongoing basis is, again, very straightforward. So yeah, I'm happy to chat about that in more detail, but briefly, I think that addresses what you're asking.
So it was about 90 to 120 days, you said?
Yeah, that's right.
Their downtime. Yeah, okay.
How is the sound level from these immersion buildings? Because I went outside a building of air-cooled Bitcoin miners, and that was a lot of sound from there. I don't know, is it the same with immersion coolers or?
No, it's definitely quieter. In fact, inside the building, you really have almost no noise at all. You might hear some liquid flowing, but that's about it. I would say it's actually kind of relaxing. You do have a fan, a cooler outside, so that does produce some noise, but it's nowhere near the noise of an air-cooled miner, either in terms of decibels or in terms of the pitch. So, those sort of buzzing hornets, as Michael Saylor likes to talk about, right? It's very loud, it's very high-pitched. We're talking about much larger, sort of slower spinning fans that are less noisy and sort of less annoying in terms of the pitch that they produce.
But
All right, and you also build them. Sorry, Martin, just gonna follow up here. So you don't build them in the same kind of racks, right? You don't build them upwards, these immersion cooling systems, but you'd rather build them flat.
Yeah. So it's sort of like turning the rack on its side in a way. You've got typically what's called an open bath. So it kind of looks a lot more like a bathtub. And you rack the ASICs or servers in that way.
All right. And is there any utilization issues there that might arise for companies who wants to build out? I mean, if you have like a lot of space in height, or is there an issue there, or is it just nonsense?
No, you're asking a really good question. And, it comes down to sort of square foot utilization in a data center is a big deal, right? This leads us, directly into the conversation about power density, which is really about what the future of compute, data processing, intensive compute is going to be all about, and the infrastructure for that. In terms of, maximizing floor space, there's kind of two ways you can think about it. Obviously, build vertically if you can. For example, in our container, we do have 2 levels of tanks, right? So you can get, some of that space savings. The other thing is to push those computers harder, right? And so that's where great cooling and the design of, Rossau's immersion system from a power density perspective is excellent. You've got the ability to remove that heat very efficiently and quickly and effectively. And so you can overclock that device harder. And that allows you to do more megawatts in a smaller space, generate more terahashes in a smaller space, which also contributes to a space savings in terms of square foot in the data center. You do have the option to sort of stack tanks, but you can also look at the power density and say, I'm going to use that capability to push the machines harder and get more from less in a space savings from that perspective.
You were leading into it. I mean, I've never been to one of these centers. I don't know how many people are needed to run or be in these centers, but are there any extra safety concerns, or are there any other regulatory considerations with this type of cooling?
Good question. So not an expert on the regulatory side, but from everything that I'm seeing, generally no. Actually, I think regulators are predisposed to liking immersion because it does reduce the energy consumption of data centers. So if you can imagine all those fans blowing in air-cooled data centers, they use a ton of electricity that's not going into the computing, which is really the valuable resource. So if you can get rid of, basically all of those or most of those fans, you do see more of that energy going directly into the compute. So the power usage is more effective in that, as a percentage of the total power being used, you're generating more computing. Only thing we've really seen sort of from a negative standpoint with respect to immersion cooling is in terms of certain fluids. And this is where there's a couple different types of immersion cooling. One called single phase immersion, where you're basically dunking the device in oil. And once basically the cold oil gets injected, as we talked about, as it rises and collects heat from the server, it exits as a hot oil. So it remains in the same state. It doesn't change phase. Two-phase immersion cooling is one where you basically have that oil injected cold, and then it rises and it actually evaporates as it collects the heat. So that's got a state change involved. So it's the two-phase fluids that have had some scrutiny, these forever chemicals that you've probably heard about. Not really relevant to single phase in terms of regulation, but two-phase, there's been some questions. There are a lot of companies working on environmentally friendly versions of two-phase fluids. I think two-phase and liquid cooling in general is a matter of national security and competitive importance for any industrialized society. So I don't think they're going away. I just think engineers and scientists will find ways to adapt and come up with new molecules to be able to make sure we can continue to offer these and make sure we're in harmony with the environment, that kind of good stuff.
Yeah, no, that's great. No, because that leads on to the next question, because you're generating all this heat, and I know Alex is from Sweden, and in some parts the industry generates a lot of heat, and that heat is then shared out into other areas. So it heats homes, for example, and I'm just wondering, is there a possibility that the heat that is generated here can be distributed out and become a little bit more sustainable, I guess. So move the heat out of that place, or maybe it adds to the generation of power or something more power. Do you know what I mean?
Absolutely, yeah. So it's called heat reuse or waste heat capture. It's becoming increasingly popular. I think Europe's actually driving requirements for data centers to do things like waste heat capture for district heating, other sorts of applications. Liquid cooling generally does lend itself to that quite well. So you've got the ability to basically take that hot oil and you can use that to two kind of ways you might set up a system, but this is where we're getting a little more technical. But let's say you want to do heat capture, you typically have what's called a plate exchanger in between the immersion system and the cooler. And basically what that's doing is, on one side, you've got the hot oil. On the opposite side, you've got cooler water. And they're basically going through two sets of coils that are in close contact over a large surface area. And that cool water then absorbs the heat from that hot oil. What you can do then is, so that recooled oil goes back to the immersion system, but that warmed up water can then be used for other purposes. So, for example, it could be used to heat a floor inside of an apartment building or inside of a mall. It could be used to help with greenhouses. I mean, people talk about that quite a bit. Swimming pools. There's a lot of other things. I think I've heard shrimp farming. Some folks have talked about using it for things like that. So, definitely ways of collecting heat from liquid cooling systems and reusing it with that sort of configuration.
Because I guess that could add to the sustainability factor of the CO2 use of a operation, a Bitcoin mining operation.
Yeah, I mean, this brings this. Let's segue on that for just a second. I mean, I look at it and say, Bitcoin mining does not produce any CO2, and the energy generation sources, right? Where the energy is coming from, right? May or may not, right? So if that makes sense.
I know what you mean. I know what you mean. Yeah.
Yeah.
I see what you mean. Yeah. But I guess it depends on where they get their energy from.
Absolutely.
Because a lot of these companies, like what's it called, Alex? Anyway, a lot of these companies are saying that they're 100% sustainable, or
from the renewable, 100%. You mean?
Sorry?
Renewable energy sources, is that?
Yeah, using renewable energy sources, 100% renewable energy sources.
Yeah, because you've been talking a lot about potentially buying credits to kind of offset their emissions.
But my point is, sorry, Daniel, my point is that a lot of companies are saying that they're using sustainable sources of energy to power their operations. Yep. But there are some that are, I guess, if you know what I mean. So maybe those companies can say, well, we're releasing heat, so that's another way that we offset our carbon dioxide use or production.
Yeah, I mean, I think it's certainly an energy efficient way. So like if you're, by using that heat, you use less energy, which that energy production might have carbon dioxide as a byproduct or something like that. I think that's absolutely true. If that were the case. The thing about Bitcoin mining that I think is really interesting, amongst other things, is you've got basically the ability to consume energy almost anywhere on the planet, right? So you can provide it, I'll call it a customer of last resort to any energy producer. And if you kind of look at the landscape of renewables, we call them renewables, but solar, wind, these types of things, they're inherently intermittent in terms of the power supply that they provide, right? It's not always sunny, it's not always windy. Sometimes you have load imbalances, you've got too much power, right? A Bitcoin mining facility can be there to be that customer of last resort and basically pay those producers for that energy when there's not demand elsewhere. And what that's actually doing is it's incentivizing the build out of renewables, right? Because you've got more reliable cash flows. So I think you couple that with the fact that Bitcoin miners inherently have to find low cost sources of power. They're chasing opportunities like this where maybe that renewable power being generated would otherwise go negative. The Bitcoiners will pay them a small price, right? That's good for their business. And as a result, what you're seeing is Bitcoin mining is being driven by renewables far more than most other industries, maybe even all other industries. I've seen some research to that effect, right? And again, because they're just, number one, able to deploy these systems virtually anywhere, in proximity to those, low cost sources of renewable energy. And number two, they need to, like they have the economic incentive to go out and find that power, where a lot of other industries are close to cities or other areas where energy may be more expensive. So I actually think that Bitcoin mining is going to contribute to the development of more sustainable forms of energy. And that we're going to have, the conversation around Bitcoin, being dirty or whatever is going to change dramatically. I think it already should have, given, like, if you look at the amount of renewables it uses as a percentage of the total network versus other industries and what percentage of renewable energy they're using, Bitcoin's already way in the lead. And I think it's going to continue to drive more renewables, and that's going to be good for everybody. So I look at Bitcoin as, I think, a pro when it comes to the environmental concerns that you were talking about, rather than a con.
That's really cool. I actually saw a YouTube video of Soluna Holdings when they were filming inside a control room. Basically, when the power got too expensive, they basically just shut down their operations because they use, I think, like wind power to power their machines. And all of a sudden, everything just shut down because the grid price, it was too expensive for them to operate profitably. So they just shut their operations down.
It's such a good point, right? You don't have too many industries that have the ability, in response to a grid signal, hey, power's getting expensive, we need to expand the availability of power, for an industry to just shut off. Like, the gigafactory can't do that, right? It's got to keep running 24/7. So it doesn't have the ability to be what's called a large flexible load when it comes to the demand on the grid, where Bitcoin miners can say, hey, in exchange for that, slightly lower cost of power, I'm willing to turn off for 5, 10, 15, however many percent of the year when the grid says, hey, we need the power elsewhere. So you're exactly right. The Bitcoiners can play that arbitrage. It's good for their cost of power. It's good for the grid stability. It's good for incentivizing renewable production. It really creates a more healthy energy ecosystem, frankly, to your point, Alex.
That's cool. So looking forward, then, what does the future hold? Because we have, as you mentioned there, you mentioned Clean Spark, and I saw some videos with Anthony Power when he was visiting Riot's facilities in the US. They are also building out like a huge amount of immersion cooling Bitcoin miners. What does the future hold there, and which Bitcoin miner is leading this trend?
Oh man, who's leading? I mean, I think CleanSpark's doing a great job. Kudos to them. But I think generally speaking, speaking to the future of this, it's only going in one direction, and it just comes back to physics. Not opinions, right? The thermal transfer capability of fluid is multiples that of air, And as the power density of devices continues to grow, right, more work faster in smaller spaces, we need cooling that can keep up with that, right? Otherwise, you run into all of the heat management related challenges that we spoke about earlier. So in that race for efficiency, right, and Bitcoin mining, and similarly in the AI space, we're seeing this adoption of immersion. So I just go back to, I think what we're in is kind of the vertical part of the S curve in a typical new technology adoption. It's kind of been developing for a while, right? It's been developed since the 60s, right? It really hasn't taken off in a large way. I think this is kind of mid part of last decade and into this decade is where we're going to see liquid cooling more or less capture the data processing intensive applications. So yeah, I'm looking forward to a lot of growth. We're certainly positioning ourselves for that. Maybe the only other thing I'd say that's of note in terms of future trends is we see Bitcoin mining and AI converging in some sense. Going back to, if you think about a Bitcoin mining operation, it's really, obtain low cost power, obtain low cost land, an internet connection, right? And then leverage those assets, right, to do compute. Well, since the emergence of OpenAI, right, we're now seeing a whole nother type of compute, has some additional complexities, considerations, different business model, but it still leverages some of those same, basic, factors that you want to compete on, low cost land, low cost power, and so on, to be able to offer a new type of compute. And so, I do see a convergence happening where Bitcoin miners are going to increasingly look to become infrastructure providers for BTC and HPC, meaning high performance computing. So that's something that, we're actually working with some folks, some miners on developing, we'll call it flexible data center designs that would allow them to transition from Bitcoin mining to HPC and a liquid cooled infrastructure over time, right, at a responsible pace, where they don't have to sort of bet the farm on HPC and, wait for the clients to show up, but they can actually sort of strategically roll out HPC on an incremental basis as they sign up new clients. And so I think that's how we're going to see, liquid cooling really transforming the data center space for both Bitcoin and on the AI side as well.
Yeah, that's really cool. And we see that this development with Core Scientific and their deal with CoreWeave, and there are others as well. As my understanding is, Wolf seems to have something going on there as well. And I know that Iron, for example, is building out like a huge capability to host both Bitcoin mining and these HPC/AI deals.
Yeah.
But it's always good to have Bitcoin miners as this complementary. I mean, if you don't have, even though there are better margins right now on HPC and AI compute, as it seems, it's always good to have Bitcoin miners as a buyer of last resort, or however you would like to frame it for a company, because you will always have this income. That's how I see it, at least.
I totally agree. And, they'll all have their own strategies, but let's think about a data center where you got both, Bitcoin mining and HPC side by side. And let's say you get a grid signal, hey, you've got to curtail, right? It's possible that what you could do is curtail the Bitcoin side of the operation and continue with the HPC side. So if you're not doing 100% curtailment, you've got a certain amount of power, right? You could keep the HPC side going and have the Bitcoin side be the flexible load, right, to help you balance things out with the grid. So yeah, I think that's going to be a really big deal. A number of other strategies that I think will be used. But if I just think about the baseline economics of what Bitcoin miners have, and it's sort of, I think we touched on this sort of before we started recording, but it's an interesting moment in history that the Bitcoin price exploded. All of these Bitcoin mining companies went out there and gobbled up all this power, and then call it 18, 24 months later, OpenAI launched their GPT. If that had happened in reverse, if history had happened differently, I think we might be in a very different world, where Mark Zuckerberg and company would be out there having gobbled out a lot of energy assets, and they would hold the power, literally, right? And not Bitcoin miners. So it's kind of interesting that it's happened in the reverse, and that Bitcoin miners have got all those assets. I think it's putting them in a prime position to become an infrastructure provider for a lot of these, giant GPU as a service type of companies. And I think hopefully, speaking of decentralization, it helps us to really, not only decentralize Bitcoin, but decentralize AI, access to, AI GPU based processing as a result of this, quirk in the way that history kind of unfolded.
Yeah.
That's
amazing. I mean, it is like you've really, because I've been thinking about these questions a lot about Bitcoin and AI but you really made it clear that it's probably going to be a mixture of both going forward, and that's because I mean my thought before was that something like Meta, Mark Zuckerberg would come and just buy out all these data centers that were used to be Bitcoin miners and just say, no, now they're for AI. Do you know what I mean? But
I know exactly what you mean. And look, I think some of that will still probably happen. Like, I'm not saying there won't be acquisitions, wholesale acquisitions of mining companies who have, large energy contracts. I think that's probably going to happen, frankly. But at the same time, I think there's going to be others who say, okay, yes, there's a learning curve. There's other skill sets that I need to be able to do AI, HPC. But look, I know how to build, data centers more or less, right? I can get, engineering consultation to figure out, how to make it a little bit different than Bitcoin, specific for GPUs. And I recognize the long-term value in being that infrastructure provider. And basically hanging on to the energy assets that I have, like literally hanging on to the power, right? To basically capitalize on that by, instead of just, either selling energy, right? Sell something more productive, right? Where you've done the work of taking that energy, you've transformed it now into, compute that clients need, or at the very least into the infrastructure that big companies who are looking for GPU hosting locations could tap into to do their work. So yeah, I think we'll see a mix of different strategies, but my hope is, and I think expectation that a lot of folks will say, I'm going to build it myself, and they'll come and they'll do the hosting. And I think you'll see there's going to be a lot of demand for that for companies that either just due to time constraints, right? It takes a while to build out a data center, or lack of knowledge, or just, other factors, will decide to actually work with the Bitcoin miners and have them host their HPC operations instead of, having to go and source power and build it all themselves.
So I guess if we're still looking into the future, then where else can cooling go then? Where else can this immersive cooling, can there be more innovation? Can computers be built in a different way, or can the liquids be developed further, or what do you know of any research and development or things going into this for the future?
Yeah, well, I think at a high level, I'll just answer your question at a high level. What we're seeing is just an increasing trend towards greater power density, and technologies designed to accommodate the growing, it's called thermal design power of chips. So the chips are becoming hotter basically, and we're seeing liquid cooling have to stretch to be able to accommodate that. So I think that's going to be the key driver. The only thing that I think could ever interrupt that would be if we end up in a new paradigm where we're no longer computing on silicon. We've got some other substrate which needs far less cooling. I've seen some stuff kind of on the very, very far horizon that might have that sort of property. But I think until then, it's going to be really a race to provide more power dense liquid cooling systems that can accommodate and keep up with the increasing processing power of these chips and processors.
So that basically the chips themselves, the GPU or whatever, is going to be able to, so they're not going to be overclocked anymore. That's just going to be standard, for example.
Yeah, I mean, GPU overclocking, ASIC overclocking, a little bit different. I think both will continue. You'll have overclocking for both to some extent. But to your point, and I think it's a really good point, I think what you'll see is there's been a little bit of a chicken and the egg problem where server manufacturers want to obviously create the most powerful hardware, but if the clients don't have the infrastructure in place to be able to cool it, then the server manufacturers kind of don't have a market, right, for a device that powerful. Once immersion cooling or liquid cooling generally is taken as a given, like, hey, there's going to be enough customers out there with this sort of infrastructure, this environment, we can all of a sudden re-engineer our servers to be pushed much, much harder. Same thing with ASICs, right? I think you're going to see that being the case as people take for granted. There's great liquid cooling systems out there. How do we maximize the value of what we provide to clients by taking advantage of that environment, right? That enhanced cooling, you will also see the devices get more powerful. So, it's been, and I think this is all really taking shape in the last, I'd say, year to 2 years, like this transition of folks on the server side saying, we are going to start building for liquid cooling, both on the Bitcoin side. If you look at, for example, WhatsMiner launched the M56. We actually had the first delivery of that to North America, I believe. Worked with that, tested that, provided a lot of feedback. They've made a lot of improvements, but that was the first immersion only ASIC, roughly, 12, 18 months ago. Bitmain's now launched their immersion ASIC, the S21 immersion, right? That's literally just come out hot off the presses. So that's that kind of evolution that, I'm talking about, where you're seeing the device makers say, we're going to build things that are specific for immersion, recognizing that infrastructure exists. And the same thing's happening on the HPC side. You're seeing servers designed specifically for immersion, no fans built into them, sort of an open design where flow can really kind of, climb through the device, grab all the heat from the chips without interfering. So yeah, and I think that's just going to compound in kind of a flywheel, right? More infrastructure, better cooling, more powerful servers. And I think it's going to mean, more compute in smaller spaces going forward.
Yeah. So, okay, one last question then, unless Alex has got one. But so you've got a mining operator now who's out there, who's listened to this, and he or she is thinking about where to next. What advice would you give someone who wants to transition into liquid cooling?
I think the best advice I can give is to make sure that your system is properly engineered and that you're not taking something off the shelf that is being prescribed to you, that they give you the same thing whether you're in a hot climate, a cold climate, what have you. Every region's different, and this is where I think Rosseau, going back to, we're really traditional data center infrastructure folks. We have folks in the team who've designed previously, 4 of the 10 largest data centers in the United States, doing a lot of the basically fluid and airflow modeling for managing heat in those environments. And so we're bringing a lot of that rigor to the upfront work of making sure, at the hottest time of day, at the hottest, point of the year, at your specific location for a given client, that we're able to effectively manage the heat load, right, based on the miner profile that you want to be operating at. That is the most important thing. And then, of course, using, industry-leading infrastructure, reliable infrastructure, ideally industrial scale infrastructure, which is how we've sort of designed the Rosseau system. I think that's really kind of the key thing. If you nail the prep for the specific site and then use the quality components, which is what we do, you couple that with a system that's incredibly power dense. That's kind of the number one thing I would say if you're looking for an immersion system or any liquid cooling system, focus on power density, because that's how efficiently and effectively you can get rid of that heat. And as miners become more and more powerful over time, and they will generation after generation, that power density is going to give you future-proof infrastructure. You do not want to be buying immersion and having to replace your infrastructure in 12, 24 months when the next generation of more powerful ASICs come out. So engineer it right, pick industrial scale quality components, and make sure that you can maximize the power density, that your immersion system has maximum power density so that you're ready for the miners today. You have maximum overclocking capacity today, stability, and ready for what's coming in the future.
I just looking in the background there, I see you're being air cooled right now.
Touche. Yes,
that's
sir.
Martin in a nutshell.
Yeah. If I could take this podcast from a bathtub, maybe I would have done that. But yeah, well said.
No. All right. Well, that's it then. We probably don't have time to talk about the future of Bitcoin, as we talked about pre-show. But no, it's been fantastic to have you, Daniel, and you have started to bring me over to the Bitcoin side. So that's fantastic.
Appreciate it. Well, yeah, guys, it was a lot of fun. It was great to meet you, Martin. Great to meet you, Alex, and wish you all the best with this Friedmen podcast. I'll be a subscriber, so thanks for having me.
No, fantastic. It was really informative.